Hello, Team SAI. This is Sarah Dunifon back with another construct post. This month, we're going to be talking about STEM activation. So STEM activation is a relatively new construct. It's developed in partnership with the Lawrence Hall of Science at University of California, Berkeley, the University of Pittsburgh Learning, Research and Development Center, and SRI International through a grant from the National Science Foundation. And it's all housed under an initiative called the Activation Lab. So I'm going to be referencing that throughout. So according to the Activation Lab, learning activation is a state composed of dispositions, practices, and knowledge that enables success in proximal science, technology, engineering, art, and mathematics learning experiences. There are a variety of activation dimensions depending on the subject area that you're looking at. So I've expanded upon science learning activation, but as you'll see below, there are specific dimensions for technology, engineering, art, and mathematics as well. So within science learning activation, we see 4 different dimensions: fascination in natural and physical phenomenon, which includes emotional and cognitive attachment or obsession with science topics and tasks. We see that one values science, so they understand the various interactions of self with science knowledge and skills and places value on those interactions within their social context. One might have competency beliefs about themselves in science, so they perceive oneself as capable of successfully engaging in science activities and practices. And they practice scientific sense-making. They engage with science-related content as a sense-making activity using methods generally aligned with the practices of science. And you'll see that some of these dimensions really hold true throughout all of the different subject areas. We see fascination popping up in all of them, values popping up in all of them, but we see some different ones depending on the subject area we're looking at. So technology and engineering have this mechanistic thinking, or mechanistic thinking. We also see competency beliefs popping up for all of them, but we see abstract thinking for art and mathematical reasoning for mathematics. And why STEM or science activation is important is that it can be a predictor for STEM career preferences. So this was a study done with middle school students specifically, which is important because we know that's a typical drop-off age for students who previously had been interested in STEM to self-select out or decide that STEM is no longer for them. So that's an important intervention age, and learning activation can be something that helps us to know if students will choose to go into STEM careers or if they have enough attachment to those subjects to really try to pursue that further. And there's a variety of ways that we can measure STEM activation. Activation Lab has been working on a number of different instruments, specifically for the ages of 10 to 14. They also have some instruments for 7 through 9, and they're working on others. There's mostly surveys available. There's also an observation protocol, and all of it is publicly available. So the links in this slide will take you right there, and you can check out all the different surveys. They are segmented by dimension. So you can see that there will be a science values survey, there will be a STEM values survey. This one here is the STEM fascination scale. It's got 8 different items, so that's just one example of what it looks like. And there's a ton more information in that toolkit. So if this is an interesting construct to you and you think you might use this in your work, I definitely recommend checking out that toolkit, checking out the Activation Lab website, and learning more and figuring out which of these might best suit your needs. I hope this was interesting and informative and you learned something new about STEM activation. And thank you so much for following along.